Welcome to my course, Game Development Basics, Week 5, Lesson 7, Object Orientation Basics. In this lesson, I'll explain the principles of object-oriented design, and that includes encapsulation, abstraction, polymorphism, and inheritance. Then we're going to create our first enemy class in our game, and then I'll demonstrate creating a child actor of that class. The first principle of object-oriented programming is encapsulation, and this means that each class controls its own variables and functions, and that those functions cannot be accessed by other classes. Encapsulation is great for preventing unintended bugs, and it also can prevent malicious activities like hacking in games. And we can do this in Unreal Engine in Blueprints by setting up our functions and variables as private. So here's a challenge. Let's find a function in our project and we'll set it as private. And here's a hint. Are there things in our player ship class that don't need to be accessed by other classes? If you would like to do this mini challenge on your own, you can pause the video now. Otherwise, I'll show you some functions that I thought should be set up as private. Here I am in my player ship class, and if we look at our functions, we can read through them and try to figure out which ones do not need to be accessed by other classes. That is to say, which functions we want the ship to handle on its own. We know that we want the ability to set autopilot on and off, and we do this through our player camera controller. But we do have get autopilot speed, and this is something the controller doesn't necessarily need to know about. The controller wants to be able to set the autopilot on and off, but it doesn't need to know what that means. So this function, which we're using to set the autopilot speed, can be a private function. And if we select on the function, we can see that we have some details here. And here, under Access Specifier, we can select Public, Protected, or Private. So I'll set this one to Private. Now if we go back to our player ship and we type Get Autopilot, we notice that that one doesn't even come up as an option because it's now a private function that cannot be accessed outside of that class. So here, our player camera class cannot access that function. Abstraction says that functions and variables only expose useful information. A class takes an input and processes them into an output, but only the class performing the function cares about how the processing takes place. Interfaces and event dispatchers are examples of implementing abstraction. For example, our player ship contains a start firing weapons function. When the player camera calls this function, it doesn't need to know what player ship does with this information. Player ship handles the start firing weapons function. It's only called by player camera. And here's another mini challenge. Can you find another example of abstraction in our project, or even in a previous project? Polymorphism says that each subclass can override the methods of a parent class based upon the input objects. And this allows flexibility in class creation without needing to rewrite functions. You can take only what you need from the parent class. As an example, we can create a missile launcher class from our weapon base class that implements a different functionality other than the laser weapon. However, it would still contain all of the functions and variables that we did not overwrite from the laser weapon. And speaking of parent and child relationships, that brings us to our last concept, which is inheritance. Inheritance says that a class can inherit from another class or classes. The inherited class gains all functions and variables from its parent class. And here's a few examples to try to better explain this principle. A vehicle can be many things. It can be a car, a boat, or a plane. Now, all of them, a car, boat, and plane, would all inherit from a vehicle class, but the car class may have a function called drive, whereas the plane would have a function called something like fly. Now, within the car class, we could have children that are different makes. So each vehicle manufacturer has its own make, and then the model inherits from that. Another example would be all mammals are animals, and then cat inherits from mammal, and then tiger inherits from cat. Now, a tiger and a lion both inherit from cat, But an elephant wouldn't inherit from cat. It would inherit from its own parent. And a final example, and this one's probably the most relevant to our game, is that a weapon could be many things, but a gun is a specific type of weapon that inherits from a weapon class. And then a rifle is a type of gun, so it would inherit from the gun class. And then an M16 is a type of rifle that would inherit from the rifle class. Let's demonstrate this in our game though by setting up an enemy base class. And to save some time and make this recording a little bit shorter, I already have my enemy base class set up. Now, we're not really doing anything new here. We've done this in previous videos. Reminder that you need to have a nav mesh bounds volume in your level. I've added one here and you can see it covers the entire floor at the moment. We covered this in week 2 of the course, so if you need a refresher, you can go back and check that lesson again. I've also created an enemy AI class called BP_enemy AI, and the parent of this is AI controller. So if you remember, we can create blueprint class, and then down here we can type AI controller and select that and create a new class. Now there's nothing in here at the moment. However, we do need this AI to be set up. The next thing I've done is created a new BP enemy base class, and this is a pawn. And you can see here, I just have a couple things. I have an arrow so I can keep track of what direction is forward. I have a static mesh, which this is one that I got from TurboSquid for free. And I've added a floating pawn movement component, and this allows us to create our pawn to be flying in the level. And the starting speed was pretty fast, so I just lowered it to 600. Other than that, I haven't changed anything else in here. And the only thing that I have implemented so far is I created a custom event called AI handling. And in here, I just have an AI move to that will get the location of our arrow and then get the forward vector of that times a number, which is 5,000 units ahead of this, and add it to our location to get a location directly in front of this ship. And we're going to move to that location. And then if it completes, we'll just call that again. So this will be a loop. And this will just keep happening until we destroy the ship, which we will set up in a future lesson. And I'm just calling this on begin play. So that's all I've set up. And then I've added one of these ships into our level. And when I press begin play, we'll notice that that ship just moves slowly by my player. And you may have noticed that I increased the spring arm length to 3000 just to give my player a little bit more view of the battlefield. And we can see again that there's my ship and it passes right by us. But what I actually want to do is show you the basics of inheritance by creating a child actor from this enemy. Here with my enemy base selected, I can right click and I can say create child blueprint class. And I'll call this something else. So I want this specific enemy to be called a darter, and it's just going to move throughout the level without any additional AI. I'll create another child called chaser, and I want to set up this one to be able to chase the player. And you can see here in my BP chaser, I have my begin play and then begin play parent. What this means is that we're going to call begin play, which will then immediately call begin play and whatever the functionality is on the parent, which here is AI handling. Now to demonstrate polymorphism, I can add my event AI handling to my blueprint graph here. And now I'm overriding the functionality of the parent. So I can set up my own AI handling in Chaser. And I want this one to move after the player. So I'm going to create a new function in BP Chaser called setPlayer. And I will get actor of class, player ship, and I'm going to save this as a variable called player. In my event begin play on my enemy base, I have it calling AI handling. So I can either delete this, or I can add set player before this, and then add player to target actor. Now, this AI will use AI move 2, but it's going to try to find the player and seek it out. And just so that we can see a difference, let's change the material on this to be just solid red, and let's add one of these into our level. And I just want to remind you that based upon the way our level is set up, anything we put into the level needs to be at 0 on the Z. That way they're all along the same plane. We're technically making a 3D game, but we want to restrict it to a 2D plane. Hello, this is Jim from the future, and there's a little bit of a technical difficulty with the remainder of this lesson. So the video footage got deleted for the rest of this lesson. So I'm going to be showing how to complete this lesson using the project, but the state of the project is after lesson 10. So there's going to be some things in our blueprints that we haven't set up yet. Just understand that we will get there in the next few lessons, but because of this, I just have to show the project in its current state to finish out this lesson. And here I am with our BP Chaser blueprint that we set up, which was a child of enemy base. And here how I've set it up is that on begin play, we're going to call AI handling, which means we're going to override it on the parent class. So again, this is an example of polymorphism. In event AI handling, we're going to set the player, which we had already set up to just find the player in the scene. And then I also do a check here that if the player is valid, we're going to proceed, but if it's not valid, then we're going to wait a second and then try again. And the purpose of this is if this was null, meaning that it could not find the player in the scene, that it wouldn't just stop there, it would wait a second and then try again. Then we have an AI move 2, which tries to move self to the player, and there's 3 possible conditions here. There's it succeeds, in which case we want to start over again. There's it fails, in which case we want to try again, which would mean we would go back here and start over. Or every second, we're just going to keep doing a check on this to make sure that it's consistently trying to find the player. And you can see here that nothing else has changed on our parent class, which is going to be the darter for this lesson. And here you can see that we have those chasers chasing after the player, and they will continue to try to go after the player regardless of where the player is in the level. And so we have our enemy base class set up, and then we created 2 child classes from that. The BP Darter, which will just move in the level without any other AI, and then we have BP Chaser, which is going to try to chase after the player. In the next lesson though, we want to be able to start destroying these ships and also allow our player to take damage as well. And to do this, we're going to set up a common component called a health component that can be used across all of these classes. And we'll show this in the next lesson.